Okay, so in this video, I'm going to be going over a couple of the problems that I think are especially hard on the 9.4 practice. So this will include numbers 7, 8, and number 9. So those are the only three I'm going to go over in this video. If you wanted help with any of the other problems, I encourage you to just try them on your own first and then come see me during lunch, or if you're absent or at home, you can reach out to me on Google Classroom and I can try and help walk you through some of it or kind of guide you in the right direction. But I think that numbers 1 through 6 and numbers 10 through 12, you should be able to use the notes and figure out how to go from there, because the answers that you get are pretty straightforward for the most part, aside from a couple fractions and no solutions that you get. So let's go ahead and dive right into it. We're going to start with number 7. And the reason why I'm doing this one is because you kind of have to access some memory from a past lesson that we had from an earlier chapter in order to solve this one. So let's start off and just dive right into it. So x squared plus 2x minus 6 equals 0. Okay, so at the top, I'm going to go ahead and write out the quadratic formula. This is something you should always do for this type of homework. Just, even when you do the test, you should just write this at the very beginning, at the top of your page, just so you can have it, right? Okay, so let's start by setting this up. So x is going to be equal to negative b, which is negative 2, plus or minus the square root of 2 squared, which is 4, minus 4 times a times c, all over 2 times a. Okay, notice I already solved for this squared because I'm just trying to save some paper and save some time. So let's go ahead and move on to the next step, which is solving for all of these multiplication problems. So now we've got 4, and then now we got to do a little bit of thinking here. Negative 4 times 1 is negative 4, times negative 6 is positive 24, all over 2. Just solving for that, okay? Now we get negative 2 plus or minus the square root of 28 all over 2. Okay, this might be the part where you're starting to think, wait, okay, I don't know what the square root of 28 is. Well, if you remember back in chapter 6, we do know how to simplify this though, right? And we know that this can be split into two things. Here we can have two things multiplied to make 28, right? And what we're looking for is a perfect square. So what's a perfect square that can go into 28? And the answer is 4, because 2 times 2 makes 4. So we get 4 times 7 makes 28. Okay, so I'm going to go ahead and write that out over here. So we get negative 2 plus or minus the square root of 4 times 7. And you might be thinking, why would I want to separate these? Well, the reason why I want to separate these is because we can use our rule from the past where we can actually make give these their own square root. Okay, it's going to be helpful here in a second. Plus or minus the square root of 4 times square root of 7. Now, I really can't do anything with the 7, but I can solve for the square root of 4, because I know the square root of 4 is 2. And so now I get an answer that kind of looks like this for now. Now, you might be thinking this could be the answer, except for this is not simplified as far as it goes. Remember that we can't mess with anything inside the square root when it comes to dividing things from the outside. If there's not a square root on this, we cannot interact. These two things cannot interact with each other. However, everything on the outside can. So we can divide everything here by 2 and get our final answer. So if we divide this 2 by 2, we get 1, which means we actually get as our answer -1 plus or minus 1, which I don't need to write that. So I'm just going to write square root of 7. And I also don't need to write all over 1, right? Because anything divided by 1 is just that thing. So I don't need to write that part. So this ends up being my answer. Or if you don't like writing things that way and you want to have the x in there, technically the answer is x is equal to -1 plus or minus the square root of 7. Now this is how you have to write the answer, because you can't split this into the two things, so it's easier to actually just leave it this way and keep the plus or minus. This still implies that there's two answers. There's plus the square root of 7 and there's minus the square root of 7. Okay? All right, that's number 7. Let's move on to number 8. So number 8 is a little bit complicated as well. But we'll just take it one step at a time. Okay, first off, let's go ahead and add 5 to both sides. We get -2x squared minus 11x plus 5 equals 0. Okay? Now from here, we can use the quadratic formula, plug it all in, and see what we get. So I'll start it over here to give myself a little bit more room. X equals -b. In this case, -b would be a positive 11. Plus or minus the square root of -11 squared is 121. Minus 4 times a is -2, c is 5. Okay, all over 2 times a. All right, now let's go down the line and solve this. So I'm going to get rid of all these parentheses. That'll be my next step. 11 plus or minus the square root of 121. 4 times -2 is -8 times 5. Well, minus the negative makes positive. So this actually ends up being, oh, hold on. Let me think about this again. -4 times -2 is 8 times 5 is 40. So this is 40 over -4. Okay? Now from here, I'm going to add these two, put them together, and I get 11 plus or minus square root of 161 all over -4. Okay? I was putting equals on the end here, so I know that I'm going to go down here. Okay. Now here's the thing. I don't think that there's anything that can come out of 161. I can't think of any perfect squares that come out of there. One way that you can tell if there's perfect squares that come out of there is, let's just look at a couple perfect squares. So we got 12 times 12, I know is 144. So that's pretty close to 161. So let's clear that and see if 13 times 13, 169. Okay, so that goes past. So it's between 12 and 13. So since the answer is between 12 and 13, I know that there's no way to solve this one, okay? So what I'm going to do is I'm actually going to just leave this as my answer. Because believe it or not, there's no perfect squares you can pull out of here. And you can't really reduce this any further. So even though this looks kind of crazy, this is my final answer. Because it still implies two answers. You got plus the square root of 161 and you got minus the square root of 161. Okay? So that's number 8. Number 9. Now number 9 is kind of crazy, I will admit. So it basically says the deer population in a forest from 2000 to 2010 can be modeled by y equals, so y equals negative 0.1 x squared plus 1.1 x plus 3. Actually, I'm going to end the video.